Hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic integration. We'll be looking at the topic integration. But before that, let us do a quick review of the previous lesson. Okay, welcome back. Now, when we talk about integration, I know we are conversant with the word differentiation. I stated it when we did differentiation in our previous lesson. I said there is a general rule that governs differentiation, and we keep working with it, that says nx raised to power n minus 1. That is how we use in differentiation. Now, we stated something in differentiation. Now, integration is just an anti-differentiation. Now you call it anti, that is to say the opposite, the other side of differentiation. You know, if we have a figure like a value like y equal to x raised to power 3, and I said find dy dx, that's differentiation. Look for the dy dx of this. That's find dy dx. You bear with me that I said the value of n is what? 3. So you start applying it with this. So you bring down the 3 back, becomes 3, we have x, then our n is 3 minus 1, which is equal to 3x, 3 minus 1 is 2. This is the formula. But when it comes to integration, the formula is x raised to power n plus 1 all over n plus 1. Now this is the formula for integration. Now if our dy ds is equal to 3x squared, now I want us, this is our answer. Now I want us to integrate. Our answer, which happens to be 3x squared. Now if you want to find the integral of this answer, what will happen is, remember the rule, we have it right in front of us here. I said the rule is x raised to power n plus 1 all over n plus 1. That is the rule. Now, if you go further into applying this rule, let's take it here. So remember the value of our n now is what? 2. So let's apply it. We now have 3 raised to power 2 plus 1 all over 2 plus 1, which is equal to 3. Okay, there's x here. That's 3x raised to power 2 plus 1. Now I have 3x raised to power 3. All over 2 plus 1 is what? 3. Remember, 3 can cancel 3, which is equal to x raised to power 3. Now you can see that we've arrived back at our question. We differentiated this, we got to this. Now if you integrate the answer, which is 3x squared, just like what we did here, you're going back to your question. That is why integration is being classified as anti-differentiation. That is to say, if you differentiate a certain number, you go back to the answer. If you integrate the answer of a certain number, you go back to the question. So that's what integration is just all about. So differentiation is a breaking down process, while integration is a build-up process. So I would like us to apply it. Remember, in integration, the formula still states x raised to power n plus 1 over n plus 1. Now I would like us to integrate x squared. Now the sign for integration is like this. So it's just like integrating x squared dx. So we want to integrate this. The integral of this is y equals to, remember the rule, our n now is 2. You write your x, you have n plus 1. So this is 2 plus 1. Under whatever thing you have here, bring it down. 2 plus 1, which is equal to x raised to power 3 all over 3. So the integral of x squared is equal to x raised to power 3 all over 3. That is the integral. Now I want us to integrate the more. If you're given a number, let me say integrate 4 over x raised to the power 5. First of all, place it in the sign of an integral 4 over x raised to the power 5. Now, according to integration, one of the things you're supposed to do is the constant term, you take it out. So this becomes 4 integral of 1 over x 5 with your dx. So it becomes 4 in bracket x raised to the power minus 5 dx. This is not supposed to be a bracket, this is supposed to be integral. That's what I just did. Is I remember the rule of indices. When you have 1 over x is the same thing as x raised to the power minus 1. So I just applied the same rule in what we're having in front of us. So when you now do that of 1 over x raised to the power 5, it becomes x raised to the power minus 5 dx. Now let's integrate this. Remember the rule. So you now have 4 in bracket x raised to the power, the rule states that n plus 1, and our n now is minus 5. Minus 5 plus 1 all over minus 5 plus 1. So which is equal to 4 in bracket x minus 5 plus 1 is minus 4 all over minus 4. But remember, in integration you always add what? Plus the constant term. So we now have it as 4 x to the power minus 4 all over minus 4. Now 4 goes with 4, we have minus 1, so we have minus x raised to the power minus 4 plus the constant term. So the integral is equal to minus 1 over x raised to the power 4 plus c. Because this x raised to the power minus 4, I just took it down to have this. So the integral of 4 over x raised to the power 5 dx is equal to minus 1 over x raised to the power 4 plus c. Now let's go further into solving some question. I might tell you find or integrate y is equal 4x3 plus 2x2 plus 4x plus 2. Now if you are being given this to integrate, remember the rule. It states that the integral of 4x3 plus 2x squared plus 4x plus 2 dx. So, and the rule for integration is n x to the power n plus 1 over n plus 1. Always learn how to note it down each time you want to solve any question on integration. So let's proceed further. So we now have the integral, which is y, as 4. Here our value of n is 3. So 4x to the power 3 plus 1 over 3 plus 1 plus 2. The value of our n here is 2. X to the power 2 plus 1 over 2 plus 1 plus 4. The value of our x here, of our n here, is 1, because 4x is the same as 4x to the power 1. So we now have 4x raised to the power 1 plus 1 over 1 plus 1 plus 2. The value of x here is 0, because 2 is the same thing as 2x raised to the power 0, because x raised to the power 0 is equal to 1, which is the same thing as 2 times 1 is 2. So we now have 2 raised to the power x raised to the power 0, because there's no x there, raised to the power 0 plus 1 all over 0 plus 1, then plus the constant term. So we now have 4x4 over 4 plus 2x3 over 3 plus 4x2 over 2 plus 2x, because 0 plus 1 is 0, over 1, which is the same thing as 2x plus c. Now 2 goes here is 2 times 2 goes here is 1. So, and this goes with this. So the value of our y is equal to x raised to the power 4 plus 2x cubed over 3 plus 2x squared plus another 2x plus c. Now this is the value of our integral. Now there's one thing I want us to do. Let's bring out this question and differentiate it and see if we can get back our question. Let's see if we can actually get back our question. So that is what I want us to do at this point, to see if we are correct with what we are doing. Now let's do that. Let's differentiate it. Find dy dx of, remember what we had there, y equal to x raised to the power 4 plus 2 x raised to the power 3 over 3 plus 2x squared plus 2x plus the constant term. Now our rule for the y dx states we have x raised to the power n minus 1, n in bracket x raised to the power n minus 1. This is a rule. Now let's apply it here. Dy dx is now equal to, our n here is 4, so it now 4 raised to the power x n minus 1, that's 4 minus 1, plus 2 times 3, which is 6 x raised to the power 3 minus 1 over 3, plus 4 x raised to the power 2 minus 1, which is 1, plus 2x, here we have 2 x raised to the power 1 minus 1, plus the constant term I say is usually 0. So dy dx is now 4x3 plus, this goes here, is 2x 3 minus 1 2 plus 4x plus 1 minus 1 is 0, x raised to the power 0 is 1, that's plus 2. So this is our value. You can actually see we came back to where we started from. So that is to tell you that if you differentiate the answer of a given integral, you get the differential equivalent. And with this, I would like to say thank you for joining us in this section. But to refresh your memory on what we've just discussed, please take the test that will appear shortly on the screen. Do well to use this lesson notes on the platform for a better information on the topic we've discussed. Thank you.